Hello students, welcome to Math Ma'am. So today we are going to take our topic statistics. Now here this chapter I have divided into two parts. In part one we are going to consider here the ungrouped data. So what we are going to take it here, we will take here how do we calculate mean for ungrouped data, mean, median, mode, which are known as central tendency. Then we'll see how the range is there. Then they will see the box plot. Then we will see here stem leaf also, and we'll see that how do we use these graph to calculate these central tendency. So what is given here? The measure of central tendency first we'll consider. So the value, it summarizes the data. Here if you will see, it says that here the measure of central tendency summarizes a set of data with a single value. So the whole data represents a single value that is most typical of data set. That means the whole value of the data lies around that central value, which is known as central tendency, and it is nothing but mean, median and mode. These three of them are called as measures of central tendency. Now here what is the measure of dispersion, how your data is spread, that we take it as a range. So first thing we will see here, now what you have learned in lower grades here, mean formula you have learned. Mean, another name is nothing but the average, right? Which is, how do we take here mean? You know that mean is nothing but the average. So you take here sum of observations. Now here this is the basic definition that you have used in your lower grades. So the same thing we are going to use here, this also. Then here total number of observations, right? So this is the basic formula of mean. This is the total number of observations. Then after that, what is the meaning of median? Median also you have seen it here. Median, if I talk about median, median is nothing but the middle value here, middle value of the data, middle value when data is, but in the median the order is very important. So we'll say that middle value when arranged data is arranged in ascending order, arranged in ascending or descending, but we always take here ascending order. So how are we going to do it here, calculate this, we'll see. But whenever we take median, there can be two possibilities here, and this is all these things we are learning about ungrouped data. Group data, there is a different ways to find out. This is all mean, median, mode we are going to talk about here, ungrouped data. Okay, so if I take here one example to understand here median, if my values are given as here 9 here, now the values are given in weight of some fruits here 5 kg, or watermelon weights here, then here there is a 3 kg, 1 kg, and then here 2 kg, right? So here what is going to be the middle value? So what do you do here? First the data must be arranged in ascending order. So first you will write on here, always whenever you need to calculate the median, you put data in ascending order, right? It's a very simple example, so you will understand, then you can apply this to any kind of data. Now here what will be the ascending order? What is the minimum weight here? I can take here 1 kg, right? Then here 2 kg, then here 3 kg, then 5 kg, and then 9 kg. So what did we say here? What is going to be the median weight here? Median weight means middle value. So how do we take here middle value? If I keep taking here one value from both the sides, will be left with only one central value, right? So what is going to be the median weight here? If I'm taking here, if I cancel from both the sides, we are left with 3. So median weight is nothing but 3 kg, right? Similarly here another example, the same example, if I add one more weight here, correct? So here this is 3 kg, which is nothing but the third value. Now there is a formula also. First I am giving you example and then I'll give you the formula to understand when your data size is large, how are you going to calculate the median. Now the same weight, if I add one more weight here, it's a 1 kg, 2 kg, 3 kgs, 5 kgs, 9 kgs, and there is 10 kgs. Now your total number of observations are 6. Now if you keep cancelling from both the sides, you will see you are left with two mid values, right? So here if I take it from both the sides, one value, you will see two mid values are there. So whenever your data here it's two mid values, then your median is going to be average of those two values. So what is the median here? 3 plus 5 by 2, which is 8 by 2. So you are getting here 4 kg, right? That's the weight. Now, what does this mean? Here, if you will see, there are odd number of observations, and here there are even number of observations, right? Now, whenever there are odd number of observations, you can get the mid value very easily. But if there are even number of observation, you will always get two mid values and you need to take the average. Now, what is the meaning of median here? The mid value, left hand side, if you will see, there are two values here, left side of 3 kg, the median, and right hand side also you see two values. That means your median divides the whole set, whole data into two parts. That's the exactly the middle part, and left side observation and right side number of observations are going to be same. Now here in the second case, if you see, we are getting median here as 4 kg, which is not the part of the data, but still we can take median as 4 kg. And if you see left hand side, there are three values which are smaller than 4 kgs, and right hand side there are three values which are greater than 4 kgs, right? So that is why we say median is the mid value. But here I have just taken very simple example. But what is the standard rule here? What is the rule we use it here? If n is odd, then median is going to be, this is the formula you can use here. If n is odd, your number of, and this is only for ungrouped data, if your number of observations are odd, you add 1 to the number of observation by 2th. Here term is going to be your median. Now look at here, how many terms are there in the first example here? If you see 1, 2, 3, 4, 5, right? So here if I am taking here, if n is 5, then your median, you are getting the term, then you need to consider the value from the ascending order. So here it's 5 plus 1th term, which is nothing but 5 plus 1, 6, 6 by 2. It is third term value is the median. And now in the previous example, you see here, this is the first, second, third value. So here first thing, because the data size is small, I have cancelled. Otherwise, you can use this rule to get, and but third value, third term means when your data is arranged in ascending order, right? So that's why here it is 3 kg from the first example. Whereas in the second example, there were n value was 6. So what happens? So this is when n is here odd. Now what happens here? If n is even, then your median is going to be here. Median will be n by 2th term, that means the middle term, plus n by 2 plus 1. See, it's not the common denominator term, and you take the average of these two, correct? Now here in the above example, n was 6, that means n by 2 means it is going to be third term, right? So here what will be the value here? And n by 2 plus 1 is going to be n by 2 plus 1, which is 6 by 2, which is 3. 3 plus 1th term means it's a fourth term. And that is why you take here median as the average of third plus fourth term by 2. Now what did we do? What did we do here? See, your third and fourth term values are 3 and 5. Don't add 3 plus 4, 7 by 2. So median is 3.5. It's wrong. Terms means you are going to consider term value, which is 3 plus 5 by 2, which is 8 by 2. That is why it was coming it as 4 kg. Right? So this is the way to calculate median for ungrouped data. If your number of terms, number of observations, number of elements are odd and even, and mean, it's you are just going to take the sum of observation divided by number of observation. Now what is your third central tendency? If you'll see, it is mode. Now what is the meaning of mode here? If I take here mode, mode is nothing but the most frequent value, most frequent or occurred value of the data. Here occurred value of data, right? Now here again, if I'm considering the same example where I'm taking the different weights here, if I'm taking here 3 kg, then here there is 4 kg one fruit here, 5 kg watermelon, 2 kg watermelon, then again here 2.5 kg, then again 2.5 kg, and here 3 kg and 3 kg. Now in this case, if you will see here, the which value, which weight, so what is going to be the mode here, which is going to represent weight. The data is about the weight. So here if you will see, if I consider the mode, 3 is coming how many times? 1, 2, 3. Whereas here 2.5 is coming 2 times, and 2, 5, 4 it's coming, kgs are coming only 1 time. So we will not consider. What is the mode means? Most frequent, most occurred value, which is 3 kg. So this is going to be the central value, central tendency, which is the central data. So all the weights are approximately here 3 kgs. Now, if there is, it is possible that in one data there can be more than one mode, right? So if there is, maybe there is a possibility here where it is more than one mode is there. So such kind of data we call it as multimodal data. Okay, this is multimodal data. That means the same example, above example, if I'm taking here, I'm just taking very simple examples. So your basics are clear. Then we will see what will be the exam type questions here, right? Here 2.5 kg, here 2.5 kg, and if I'm taking one more time 2.5 kg and 3 kg and 3 kgs. Now here in this data, if you will see, 3 is coming here 1, 2, 3 times, whereas here 2.5 is also coming 3 times. Now you can't decide only one weight as the most, which is the most frequent value, because they both are coming 3 times. So you will write down here there will be two modes, which is 2.5 kg and 3 kg. So in this case there is two mode also possible. If there are more than one value which is coming the same number of times, then you will have multimodal data. Okay, so this is the way we calculate here mean, median, mode of ungrouped data. Then what is the meaning of range? How do we calculate the range? If you will see range here, it's given here. It's a measure of dispersion. That means how spread out a set of data. That means how to calculate the range. We'll take the highest value and we'll take the lowest value. And if we take the difference of this, we will get how much, what is the range and how the data is spread. So what is the next one here? Range. Right here, range is nothing but dispersion or spread of data. Spread of data. Now here, if you will see, whenever we calculate the range, it is always the highest value here, highest value among the data minus the lowest value. So here it is highest value minus lowest value of the data. Now, if I take the same here example, the above example, 3 kg, 4 kgs, 5 kgs, 2 kgs, this one here, what is the highest value? If you see, what is the highest weight? It's 5 kg minus the lowest weight is 2 kg. So the range is 3 kgs, because here 2 kg to 5 kg total, the data is spread from 2 kg to 5 kg. So that becomes the range of the given data. Now, whenever we take this ungrouped data, your median part is very important. So, what is the meaning of quartiles? Quarter means 1/4, right? So, what happens here, if you will see, quartiles divide the order set of data. The moment we are saying order set means we need median, because we will arrange our data in ascending order only in case of it is needed for median, into quarters. Quarters means it will be into 4 different parts. So if I'm taking here, if this is the data length, see, I'm just telling you here. Now in the middle there will be here median, Correct. So this one you are starting from here. This is there. Now the lower quartile means it is going to be 1/4 here, which is known as Q2, Q1. Q2 is going to be median because it is the middle value. Now, if you will see, the whole data is divided into four parts. You can see that. So Q3 is nothing but the third quartile or upper quartile. You can see that the median is another name of second quartile, which is Q2. Then the lower quartile. So Q1 is known as first quartile or the lower quartile is the median of the observation. We'll take one example. So you will see here, all these are going to be, there will be the number of observations. The middle value is going to be the median. So you can take it the median of the first minimum value to Q2. It is going to be here the Q1. Then here the median of the observation to the left side of the median of an arranged set of observation. Similarly, Q3 is known as the upper quartile here or the third quartile here. This is called lower quartile also, is the median of the observation of the right side of median if the data is arranged in the proper ascending order. Now interquartile range, we write down, take it as IQR. That is always here Q3 minus Q1. Sometimes you get here semi-interquartile range also. That will be taken as Q3 minus Q1 by 2. So let us take one example here and we will see here how we will calculate median, lower quartile, upper quartile, and then interquartile range, because this is very important part when you will take the box whisker plot. We are going to take here box whisker plot also and to calculate the median. So this is your ungrouped data. Right, this is one of the example where it's given here. What do you need to calculate here? You need to calculate median, which is Q2. Lower and upper quartile means Q1 and Q3, and the interquartile range is IQR of this set data. So first thing, whenever you have any data, ungrouped data means it is not in the class interval form or it is not grouped, correct? So the first thing, whenever you see this kind of questions, the first thing you are going to arrange it in ascending order, because without arranging in ascending order, we can't calculate the median. So what is the lowest value? If you see here, it is 2. So I can write on here 2. Then after that there is 4. So we can write on here 4. Then 5. Then 6. So here 5, 6, and after 6 you will see here 5, 6 done. 7, 8, 7 is not there, so it will be 8, then 9, so it's a comma 8, comma 9, and then after that 10, 11, this is 10, 11, and after 11 you will have it here 13, right, and then you are having 15. And after that, the last two of them are 19 and 20. And always cross-check, count the total number of observations, because sometime while writing, you may miss some of the values. So let us quickly calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total number of observations are 12. We wrote everything 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So you can see that it is the same here number of observations. Now you have arranged your data in the ascending order. Now how to calculate the median? Because you are NS2. So either you calculate, or I have told you the rule also. What is going to be the median? You will, here it is 12, not 2 here, right? So median is going to be 12 by 2, which is sixth term, plus next term, which is 7th by 2, when data is arranged in the order. Because what was the rule I said? N by 2th term plus the next term, which will be plus 1th term, and its average is going to be median when your N is even number, right? So sixth term from the left or right, 1, 2, 3, 4, 5, 6 and 7. So which two values are there here? You see 9 and 10 are the two mid values. So 1, 2, 3, 4, 5, 6 and 7. So 9 plus 10 by 2, which is 19 by 2, which is 9.5 is the median. That means your whole data will be divided here. It is 9.5, which is Q2. Here you can write down Q2 also. right? Now you can see that the whole data is divided into two parts, left side of median and then right side of median. That also, if you will see, there are 6 terms. Here also this side there are 6 terms. So it is equal number of terms. Now how do we get here lower quartiles? Our first part we got it here. Now here to get the lower quartile or the first quartile, which we call it as Q1, I have to take the median of the left side of the value. So 2, 4, 5, 6, 8, 9. Again, there are 6 data. So N, 5 and 6 is the middle terms, two middle terms, because here now N is 6, right? For left side. So your median is going to be third. 6 by 2 is third plus fourth value from left side of the left side of the median. So what is going to be your third and fourth value? 5 plus 6 by 2, which is 11 by 2, which is 5.5. So what is where the 5.5 will fall here? Somewhere in the middle, which is going to be your Q1, which is 5.5. You can see that each median, and here it will divide the data set into two equal halves. So 5.5, left side there are 3 values, right side also there are 3 values. Now how to get the upper quartile? Upper quartile, you need to find out the median of this whole data. Again there are 6. What are the bit values? If you will see, 13 and 15. So what is going to be your Q3 here? If I take here upper quartile, which is known as third quartile, upper quartile, which is Q3, and if you take it here, now third value, so again there are 6 terms. So third and fourth, when you are starting from 10th, you'll not start from 2 now, because your data is divided into two parts by the median. So here you will take here 13 plus 15 by 2, which is 28 by 2, which is 14. Now 14 is going to fall between 13 and 15, and here you can write down Q3, which is 14. So you can see that here you calculated median, you calculated lower and upper quartile, and now how are we going to get the interquartile range? This is interquartile range, which we call it as IQR, that we always take it IQR, which we always take it as Q3 minus Q1. Now Q3 is 14 minus Q1, right here. If I take it, it is Q3 minus Q1, the upper quartile minus lower quartile. So upper quartile is 14 minus Q1 is 5.5, and if you subtract these two, you will get the interquartile range, and that is coming it as 8.5. So this is the way you calculate Q1, Q2, Q3 and interquartile range. Now, whenever you are having any data, you have to remember that there will be a 5-point summary set. Mostly this will be asked in the question. Any kind of data, whenever the data is ungrouped data in ascending order, or the data is given in stem leaf, or mostly it will be used when the data is given in box-whisker plot. So what does this mean here? We have already seen whenever they say 5-point summary means, first thing, it is going to be the minimum value. Then just now we have seen how do we calculate the lower quartile. Then it will be median, upper quartile and the maximum value. These 5 values set is known as 5-point summary of any data set. Now how do we use this? Here let us take one example, and we will see here how to construct stem leaf. You all have learned in lower grades also. Box whisker plot, I'll tell you how do you make it here, right? So you will see here box whisker plot also, which is here mostly used to calculate the median Q1, Q3 interquartile range. So how do we do it here? Let us take one question. You will understand how do we do it. And in this question only, I'll let you know how do we draw the box whisker plot. Right, so here if you see here already the data is, you don't, whenever you are having stem leaf diagram here, the data is already arranged in ascending order, because how are you going to read it here? If you see, the key says left hand side 3 and right hand side 8 makes 38. So you can see that the data is already there, 38, 38, 39, then 40, 43, 44, 44, 47, 48, then 53, 57, 58, 58, and then 61. So you can see the data is already arranged in ascending order. So this is ungrouped data, but it's already, you don't need to arrange it in ascending order because stem leaf diagram is already representing data in the ascending order. Now, what is the minimum value when you will see the first value when you start? You can see that it is 38. Here, what is given here, stem leaf diagram shows the number of diners at a restaurant during a 2 weeks period, right? So this is number of diners. So here 38 diners, this is your data. Then how do we calculate the median number of diners here? So to calculate the median, first you should know how many observations are there, right? So if you will see here, how many observations do you see here? It's a 3, and then here 6, 6 plus 3, 9, 10, 11, 12, 13, 14. So your n value here, if you will see, which is number of observation, is 9, 9 and 5, it is 14, correct? So whenever you are having, this is odd or even, this is nothing but even. Now whenever your n is even for ungrouped data, you will have two mid values and you need to get the average to calculate the median, right? So here, how do we do it here? Now n is this, so median is going to be equals to, you take n by 2th term. So 14 by 2, it will be 7th term plus the next term. You can just remember as you will get the midterm and then you can add to get the next value. So here 7th and 8th term average is going to be your median. Now count here, what is going to be your 7th and 8th terms? So 1, 2, 3, 4, 5, 6, seventh term. So what is your seventh term? It's 44 plus 47 by 2. Now median is 45.5 diners, right? Now here we know that we cannot have 45.5, but just for the data we can have it. Now where will it fall means 46th, right, or 45th we can take it. So it's going to fall somewhere in the middle, right? So this is your Q2. Now the whole Q2 is going to divide because median is your second quartile, right? The middle quartile here. So it is dividing the whole data into two parts. So 14 total weeks divided into 7 and 7, correct? Now after that, what is the next part they are asking here? Find the interquartile range here, right? So this one was part B. Part C says here, you know that IQR, which is interquartile range, is Q3 minus Q1. First quartile, which is the lower quartile, where your N, if you will see the first half, median is dividing into two equal half. The first half are having here 7 observations. So 1, 2, 3, 4, 5, 6, 7. N is 7, which is an odd number. And whenever it is odd number, you know the rule is going to be plus 1 by 2th term, right? Because term can't be in decimal. So 7 plus 1, which is 8, 8 by 2, we take it as 4th term value as the lower quartile. So what value is there here? 1, 2, 3, 4. So your value here, Q1 is having here 40 diners, right? Because fourth place value, it is 40. Similarly, if I need to find out here Q3, which is upper quartile, we are going to consider the second half, and in the second half also their n value is 7. So from the middle, if I'm taking here fourth term to the right side here. So this whole data is divided like this. This is first set of data, and then 47, 48, this is second set of data. Now from here, if I'm calculating first, second, third, fourth, so your upper quartile is nothing but 57. So your interquartile range is going to be here 57 minus 40, that is going to be 17 diners, right? So here now again you have to construct the box whisker plot for this. So what do we need to remember here? 5-point summary here, because whenever you make the box whisker plot, box whisker plot here, you use here for 5 point summaries. And in 5 point summary, what is the first thing? Minimum value you should have, Q1 you should have Q2, which is the median, then you will have here Q3, which is the upper quartile, and then you should have the maximum value of the data. Now, what is the minimum value of the data here? What is the minimum number of diamonds among all? It is 38. So minimum value here, it is 38. Q1 we have calculated 40 already. Then Q2 we got it as 45.5 already. We have calculated that also. And then Q3 is 57 and maximum number of diners you see it is 61. So if we are making here box whisker plot, we are going to mark these things on this kind of graph. Generally they will give you this kind of graph and you just need to drag those lines and boxes to make the box whisker plot. So first we will mark here minimum value. There are only 4 divisions, so each one is going to be here 2.5. So if I take it here, 38 is going to be 38. Then you need to mark here 40 as Q1. So I can take it from here to here as Q1. So this place is going to be your Q1. Then Q2 you are going to mark it as 45.5. So in the middle it's 45. So from here to here, if I take it, it is going to be 45.5, which is Q2, which is going to be your median. Then here Q3 is 57, so 55, then 57.5. Here, if I'm taking little bit here, this is 57, right? And then maximum value is 61. So the first value is 62.5. So I can take it here. Now maximum value, again the minimum and maximum value lines are going to be smaller. So I can take it here from here to here, right? Then here you have to just join it. So if I join this, you are going to join Q1 to Q3 with the same line, and minimum value will be joined in the middle this line. So this is called box whisker plot. They will give you the already the lines, so you don't need to draw the lines. You just need to copy paste or drag those boxes to the graph here. So I'll just show you here how it should look. Side you must write on here, it must be written here number of writers. So this is the way we draw the box whisker plot, where we always include 5 point summary. There will be minimum value, there is going to be maximum value Q1, Q2, Q3, and you will make that boxes. Now let us see some exam based question here. If you will see the weightage for statistics in your paper will be from 15 to 20 marks, right? If you'll see here, it's a 17 marks question. It's given the Tropic of Cancer and Capricorn are lines of latitude that are parallel to the equator of the earth. These are 11 countries on the Tropic of Capricorn and 17 countries in the Tropic of Cancer, right? So this is there. Then after that, in this question, you will analyze the data on the life expectancies of countries on these two tropics. Click on the tab title to switch between the tropics. So there you will have the online tab where you can switch to see the countries which are there. It's parallel to here. You can see Tropic of Cancer, and here it is Tropic of Capricorn, right? Now, what is given here? First one, it is line of best fit. It is going to be what is here. Scatter graph is given. So the relationship between life expectancy and the other factors is represented on the following scatter graph. Identify the correlation. You know that whenever there is a scatter graph, it can be there is no correlation. They can be positive, negative, strong, or strong positive or strong negative correlation, right? So you have to identify here based on what will be the life expectancy depending on which factor. First one, it's given here annual carbon dioxide emission here million per ton, million tons per year. Then here position in the ranking of the top 60 countries with the best healthcare system, because if the healthcare system is better, then automatically life expectancy will be high. Then the annual mean working number of hours here and GDP per capita. Then here life satisfaction 10, highest life satisfaction. Now here if you will see the first one graph, you won't be able to identify here any of the correlations. So you are going to bring here none tab, right? You need to take this tab, you can type also. Now this one here, if you see, it's going coming down, and but the all the values are not tightly packed, so it is going to be here negative, right? It's going to be negative correlation. Then here, because all the points are very close to each other, it is going to be strong negative. Then after that here, if you will see, because it's going in this way, so here and this also, they both are positive, but because here the all the points are very closely together, so it is going to be positive. And the last one, you can take it here, strong positive. So these are the types of correlation you will always get it in the scatter graph. Now after that, what is the question here? Given the next question says there are 11 countries positioned on Tropic of Capricorn, and the life expectancies in 2021 for these countries are given below. So this is the data of 11 different countries, and how it's given here. This the data is for 2021, right? Now, what is given here? The first one, the lowest age life expectancy of one of the country, it is 59, and the highest among those countries, it is 85 years. Now, you need to write down here, there are, so N is nothing but 11. You'll see here, there are 11 here, so total number of observations are 11. Write down the missing values in the Box-Whisker plot. So here they have already drawn the Box-Whisker plot. You need to fill the value. If you see here, the minimum value, you see 59 years, that's the minimum expectancy, life expectancy of one of the country. Then what is going to be, first we are going to fill here median, because this value is your Q2, this value is your Q1, and this value is your Q3, which is the upper quartile, and this is your maximum value. You can, your maximum life expectancy, you can see that it is 85 years. So in this box you can fill 85. Now how do we get the median? Median, you know that whenever we need to get median, because n is odd, we get median will be here n plus 1 by 2th term, right? That is going to be 6th term. So in your data, if you see, it's already arranged in ascending order, first, second, third, fourth, fifth, sixth. So this is going to be your Q2 here. So what are you going to fill here? It is 71 years. It is the median a life expectancy age. Then you need to take the left side of the median. You need to find out the median, and the right side of the median to get the Q3 upper quartile. So here, now if you see, how many values do you see here? 5 observations are there. So your median of this is going to be 61. That means your lower quartile is going to be here. This is Q1. Similarly, right side of median, it is again, there are 5 observations. So 70, mid value is going to be 79. That is going to be Q3. So you can fill here 79, which is Q3. So all these are 3-marker questions. And after that, the next 7 sheet says, what is determine the following measure of dispersion? Dispersion means how data is spread. So what is going to be the range? Highest life expectancy age minus lowest value. If you take it here, 85 years minus 59, if you'll do it, you will get the answer as here 26 years. So the range here, it is 26 years. And how do you get here interquartile range? You know that interquartile range is Q3 minus Q1, lower upper quartile minus lower quartile, which is 79 minus 61. And if you do that, minus 61, you will get it as 18 years. So this is the data here. Now here this is done. Then the next 70 questions are there are different questions of 10 marks here. What is given here? The first one, news headline, the life expectancy of the Tropic of Capricorn is higher than the life expectancy on the Tropic of Cancer. So they have given this here, and you need to observe this data. See here, the Box-Whisker plot, you have to compare this given Tropic of Capricorn and Tropic of Cancer. How can you decide here? You can see that the life expectancy is lower, because Tropic of Capricorn, we have already filled the data here, right? What is given here? If we take this is 85. Now what is the upper quartile? We have already taken here 61, 71. So this is your 61, this is 71, and Q3 you got it as here 79, and the minimum age here it is 59. So we are going to read this data. We have to compare both uh, This one, both the box whisker plot. It says that scroll through the image gallery to see the life expectancy data of the Tropic of Cancer and Tropic of Capricorn here, right? Then what do we need to find out here? Image 1, this is image 1, life expectancy from 1950 to 2020, Tropic of Capricorn and Tropic of Cancer. It is again, this is the data given here. Blue color dots are representing Tropic of Capricorn and then Tropic of Cancer. Right, so here when what do we need to find out here? Analyze the data on life expectancy and comment on the headline in your answer. You should identify the elements relevant to your comparison. You need to compare both, right? Then compare measure of central tendency means you need to compare its mean, median, mode. Then measure of dispersion means it is going to be range and any other relevant information. Comment on headlines. Justify the degree of accuracy of your results. Tropic of Cancer here. This is Tropic of Capricorn first, Capricorn, and this is Tropic of Cancer. Now, if I'm taking these two, so first you compare the minimum age. Now, if you will see the minimum age, both the countries here, all the 11 countries are having here, minimum life expectancy age is 59 years. As the first quartile, it is 61 year, but here it is 67 years. So using this, you can't till now, you can't decide here, but here if you take the median, because the minimum, it is the middle age where half of the values, half of the people are having less than 71 years of age and more than this. For Tropic of Cancer, the age is less. Similarly, here if I take here Q3, 79 years, upper quartile is higher than the Tropic of Cancer and Tropic of Capricorn, and the maximum life expectancy is 85 years, whereas here only 81 years. Other than that, also, if I'm taking here interquartile range and range for both the countries, because range is going to represent the spread over the whole data dispersion, right? So it is 85 minus minimum value, and for this one, for Capricorn here, how much are you going to get it? 85 minus 59, which is 26 here is the spread, whereas for the second part, it is 81 minus 59, and if you're taking that 81 minus 59, you are getting only 22 years. So you can see that the life expectancy, people live more in Tropic of Capricorn for longer, it's a longer duration than Tropic of Cancer. Similarly, if you take interquartile range Q3 minus Q1, for the first one it is 79 minus 61, and for Tropic of Cancer it is 76 minus 67, and if you are taking that minus 61, it is 18 years, and whereas this is 76 minus 67, it is only 9 years. So this shows that all these elements shows that Tropic of Capricorn, the people will live here long than Tropic of Cancer. So here it's written here, analyze the data on life expectancy and comment on the and headline, right? So what are you going to do with it? But it says that Tropic of Capricorn has higher or bigger, what is there here? It's a median here, median, interquartile range and range, right? Interquartile range and range, right? Which shows that using this we can say that therefore Tropic of Capricorn, in Tropic of Capricorn here, Capricorn, life expectancy is higher, right? Life expectancy is higher. Comparison, you have done it here using analyzing data. How do you comment and justify the headline? What does it say here? Scroll through the image gallery to see the life expectancy data of Tropic of Cancer and Tropic of Capricorn. Now this is there. It says that life expectancy from 1950 to 2020 of Tropic of Capricorn and Cancer, it's given here. Now, slow, if you will see this, how are you going to comment and justify that the result then when you have given it the life expectancy in Capricorn, it is higher? How are you going to do it? So, whenever you are writing here, comparison, you have done it, right? You have written all the data and you have shown what is greater, what is this. But whenever you are writing this, now here, if you will see, initially, if you'll see, the Tropic of Cancer is having lower high life expectancy till which year here? Here, if you will see, till this year also you can take it. So approximately till 2000 here, till 2000, this is 1995, you can say that. Till here, if I'm taking this, the life expectancy, it is correct up to, right, 1980 to 2000 or 1995, that Tropic of Cancer is having less life expectancy than this. But if you will see slowly in between, here it is greater, because in 2000 till 2000 here, till 2010, and this is 2015 till 2020. So 2000 to 2020, now gradually the gap between their life expectancy is decreasing. If you will see here both the graph, if I take this graph, right, it is coming less steeper, whereas this is, it is more steep, right? So here what can we say, that here this data is correct till 1995, but after that slowly gradually incorrect after here 2000, right? So here correct up to this means here you can write down incorrect. This data headline is incorrect after 2000, right? It is 2000. So this is your first pointer. What is the second pointer here? You can say that here the gap between here, there was a gap. So gap is narrowing also, you can write on here. Gap is narrowing here, narrowing with the time, right? With the time from 1950 to 2000. Then slowly after that, what you can write down here, give here Capricorn life expectancy is higher till 2000, till 2000. After that, which is increasing here, life expectancy of, you can write on this also, life expectancy of Tropic of Cancer. Tropic of Cancer is increasing gradually and it is slightly more here, slightly more. In which year, if you'll see the graph here, in which year it's a slightly more than Tropic of Capricorn, you can see that it is starting from here, right? 2000 to 2020, slightly more from here, 2000 to 2020. But after that also, again, if you will see the gap between, again, see slowly this is coming here. Tropic of Capricorn was decreasing, but slowly it's going to start increasing, if you will see the, because again the gap between from 2000 to 2020 also, Capricorn is also gradually increasing, right? So any these kind of comment, because the data is not uniform across the years, right? Headline was headline was correct for the past. So first you are taking the data, then you are generalizing the here statement here. The data was true here but incorrect recently, right? This headline is incorrect recently, right? Now here, what else you can write on here? Headline is outdated because they have to work on this. Headline is outdated. It is based on the previous data, but they are not considering how is it gradually changing, right? Now one more thing, because you are learning about the graph here, you can write on here cancer has higher slope, right? Higher slope means it is steeper. Higher slope, that means it is steeper. So Capricorn has lower slope, right? But gradually increasing. Cancer and expected to increase, because if you'll see the graph here, expected to increase in some years, because if you'll see here again, the blue color dot was here going above, see it is below, this also below, this is also, but gradually it's going up, right? So this is the comment. Then how will you justify this? Here you can say that it is inaccurate because as Capricorn has only 11 countries, only has only 11 countries, and here whereas Cancer has, Tropic of Cancer has 17 countries, right? 17 countries, and the number of people in both the countries will not be same. So this is your first one, that again number of countries are different. Why? Then the number of people are not same, number of people are not same in both, right? Here, other than that, here is accurate for 1950 to 2020, right? So this is this one here. The answer is possible in both the ways here, right? Because your data is accurate for this, so headline is correct here. See, you can write on both the answer because it's your choice that which data you are considering. Headline is because the data here, headline is analyzed based on central tendencies, which is mean median mode, central tendencies and dispersion, right? So based on that, the data is accurate because you are taking only for the first 70 years, right? So again, you can write down here is inaccurate as here image. When you see the image one, because see, if you use that it's fine, but when you are taking this image, you can't identify what will be the mean or what will be the median, right? So here image inaccurate as image one does not show mean or median for life expectancy. Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.